Okay, here we go with the intro video for arc length. So I'm just going to go ahead and try to motivate the whole topic for you. This is one of the first things we're doing in our applications of integrals. I'm trying to change that color. So what can we actually do with integrals? And one thing we can do is to find the length of a function, of a curve. You know how to find the length of a line. It's like real easy to do. But if I ask you to find the length of like a parabola, that's not too easy. Integrals will help us be able to do that. So if I gave you like the parabola y equals x squared, let's say it's from 0 to 1, and I ask you what the length of that is, of that curve is. I don't know, but with integrals I'm able to do it. This is useful for calculating distance that something moves. Things don't always move in straight lines. How long a string do I need if I have to, if it suspends, you know, if my string is curvy, and I need it to be a certain shape for a project or whatever, how long does it need to be? I don't know. But anything you need to find the length of in physics and engineering and whatever it is, this is a useful tool. So this entire lesson is one formula. And as always, I don't like formulas. Sometimes you have to know them. But I'm going to teach you why it works. That's going to be the point of this video. So, for just a moment, forget the parabola. Also, my axes were like tilted. So I'll draw them better this time. So, here's how I'm going to do it. Pretend I've got a function, f of x, and I want to find the arc length of it from a to b. What I'm going to do is think about it as breaking this curve up into a bunch of lines. And letting the length of that line, of all of these lines, get really, really, really small. I'll add up more and more lines, and the lines are going to get real small. So let's see if we can figure out, like, what the length of one of these lines is. Just one of them. Because the entire length of the curve is just going to be adding all of them up. So I'm taking this here to say I'm zooming in. So let me actually do a proper zoom in. I've got my function here because this line is so small. The curve is there, but it looks almost like a line. But the curve is actually there. And then I've got a line which approximates it. As these lines get infinitely small, the way I can find the length of a line is by the Pythagorean theorem. Because these lines are getting infinitely small, the change in x from one of the lines I'll call dx, and the change in the y value on one of the lines I'll call dy. This side length, by Pythagorean theorem, I'll call it c. I know c is dx squared plus dy squared. Sorry, c squared is that. So c is the square root of dx squared plus dy squared. So the formula for arc length, it's the integral from my start to my finish of, because I'm adding up, taking integral just means adding up, I'm adding up all of the lengths of these lines along the curve. So I'm adding up between A and B the length of all of the lines. Now this looks really weird, so let me actually do something to it to try to simplify. I'm going to factor out a dx squared from the entire square root. Dx squared times 1 plus dy squared over dx squared. I'll erase that, make more room. I'm going to cancel this square root. That leaves me with a square root of 1 plus dy over dx all squared. And then that dx goes at the end because it's dx squared under a square root. This is the arc length formula. I added up. An integral is just an integral. This is going to be the thing that happens through the entire class. An integral is when you're adding up a ton of really, really, really small things. Infinitely many, infinitely small things. That's going to be the common theme. This was a Riemann sum. This is how we did area. This is how we did volume, or how we're going to do volume if you haven't seen it yet. And now we've got arc length. So integral added up very small lengths of these little segments along the curve A to B, and I got this formula out. So dy dx is just the function. So I take the derivative of the function, I square it, I add 1, take the square root. And that's basically it. The whole section is just a formula. The algebra can get messy, but apart from that, it should be pretty straightforward. And I hope this helped.